All right, you guys. Well, welcome to Data Viz. I am obviously not your professor for the semester. I'm your imitation, temporary faculty. And so Professor Cafella was going to be back shortly, but she's at an international environmental convention, and so asked if I would just pop in and get you guys going. So she's going to give you all of the details about logistics for the class and all that kind of good stuff. I'm just sort of beginning to sort of pull the ripcord and start to get you guys thinking about data visualization and all that kind of good stuff. So today's basically going to be a overview of some of the approaches that you can take to data visualization. So when we talk about presenting data, that can come in many different forms. That could come in like an infographic style of thing. That could come in a scatter plot. That could be a table. There's many different ways to effectively communicate quantitative information, and that's one of our takeaways from our program, that we want you all to be able to collect rigorous data, present it to others, be able to effectively tell a story, communicate a message with that stuff. So this is a great class where you guys will be playing around with that and taking different takes on perhaps the same data, different audiences, etc. So today I just wanted to give you a bit of an overview and make sure we're kind of approaching this the same way. So, for example, and you guys are welcome to interrupt me if you have any questions or if something doesn't make sense or one of my figures is blurry or something like that. Just go ahead and let me know. Okay, so what do you guys think about this? What do you guys think about this headline? Good, bad, indifferent? Confusing? What's confusing about it?
Arctic ice is the key. Melting ice is an indicator, but it's not melting.
Cool.
Sensing satellite images and all of that. So maybe not in that specific area, but we can see it encroaching into the center.
Okay, cool. So maybe something doesn't quite seem maybe right with this figure, or something seems a little off.
I feel like it might be intentionally misleading.
Yes, intentionally misleading. Why would anybody ever want to mislead us? Absolutely. So this is a political newspaper from a conservative religious group that has increasingly gotten, I think it's fair to say, objectively crazier and crazier over the last few years. And one of their things is they like to think there's no such thing as climate change and no such thing as many other factual challenges that we face. So if we read this headline seems to give us some information, tells us some words. It says, hey, this is what's going on. And they kind of give a quasi-graph-like thing. There's some red jiggly lines up there, and it looks like the line is kind of going up, kind of going down, but it's mostly not changing, right? So it's maybe a little changing, but it's not really changing. And so the headline says, yeah, stuff is changing, but it's not, right? So easy to see that if you weren't paying attention to Arctic ice or had a busy day and weren't reading too close, like, yeah, okay, whatever, that's kind of weird, nothing's going on here, right? That's one message from one person presenting some information to you. Here is perhaps a more accurate display. So this is the volume of Arctic sea ice in 1980, in 2000, and in 2019. Does that look like that tells you a picture?
Yes.
And what picture does that tell you?
Looks like
It looks like it's getting smaller, right? That doesn't look like it's not melting. That doesn't look like it's kind of equivocal or it's kind of up, it's kind of down. And what if we went even one more and added a map onto there and showed you what that looks like, right? So clearly, And the other thing, as you guys are getting into this more sophisticated presenting of information, there's not necessarily one right way. There are many possible ways to have an effective communication. Maybe, and this person thought it was some cubes and maybe a map, and that looks totally great. You could have maybe done an equally good job with, I don't know, a line plot or something else. So it's not as if there's one way. You have your own aesthetic. You have the data. Now, a lot of times, because of the nature of the data or the way things just sort of fall out, there's maybe some natural, I should probably do a bar chart on that, or we should probably do a scatter plot on that, or whatever. But there's always alternatives. And just like your writing, the game is going to be with your data visualizations, going to put this out there and then revise. I'm going to try this, tweak. Green would be better. I don't know. Hollow would be better. I don't know. Let's try. So you guys are all learning how to walk at this point, right? So we first crawl, and then we crawl faster, and then we kind of stumbling walk, and then we kind of walk nice, and then we kind of walk faster, and then we kind of jog, and then eventually we can run, but that takes a while, and nobody's going to expect you guys to be able to, run an Olympic race, this first way out. The point is, give yourself some grace, give yourself some opportunity, and when you do have an assignment and you're trying some, go and try this. And if it's like the straight ahead way, yeah, totally, I'm going to do it that way. But then, I wonder if I used triangles instead of circles or whatever, and you might stumble upon a way that's better and more effective. And so the game is always getting better. There's never just like there's never a perfect essay, there's never a perfect figure. It's always getting tighter, getting more effective, and it's sort of, we never quite get there, and that's an okay thing. Cool? In general, most of the stuff that you'll be doing this semester, and indeed in your career, is about relationships. So all that we're doing with our science is trying to predict the future. That unifies all of our science stuff, right? So it's saying, if I know the rainfall and the nutrient level and the amount of wind and the then I can predict with a pretty good certainty how many corn seeds are going to germinate and grow into plants, right? And so all the stuff that we're working on is trying to understand, predict. So when it comes to data, we're trying to look for relationships, sometimes very complicated relationships, but at least some type of relationship. So when somebody's hair color is like this, how tall are they? When someone does this for studying, how does that influence their grade, right? All that kind of stuff. So we're always striving for clarity and striving to see if we can see a relationship. And at the simplest version, that's how does A relate to B? When A changes, does that make B change? Another way of doing that is to say, what's your hypothesis? So I hypothesize that as A goes up, B will go down, or whatever, right? And so we make that statement, and the visualization is a way to help us take a bunch of data, which is usually tabular, numbers in a spreadsheet, and could be many, many rows. And so theoretically, if you were, I don't know, an Android, you could look at all those numbers and then sort of see the pattern, but that's not how we work, right? We're a visual species. So we've evolved hunting for fruit in the savannas, and we're looking for, hey, where's that purple fruit, or where's that pink fruit, or where's that orange fruit? And so our brains are optimized to look for patterns. And so it's easier. There's a place for tabular data, absolutely, but it tends to be easier for us to see visual patterns rather than a bunch of numbers in a large giant column. Gesundheit. Okay, so let's roll up our sleeves and do a little work. So have a look up at this figure. Oh, it's going to be very exciting. Everybody drum roll. Drum roll. Oh, my God. Oh, it's such a drum roll. Oh, my God. Oh, look at that. What the hell is that? I don't know. All right, so stare at this for a second and quietly see if you can decipher what is being presented here. And then in a minute, I'll ask you guys some questions, but just stare at it for a second. Okay, what do we think's going on?
It's the amount of mascot costumes being sold between the West Coast, Central and East Coast.
Okay, Dylan thinks it's stuff being sold. Okay. Okay. What else?
I thought it was how many like mascots there are.
Okay, maybe it's so I've got to vote for prices. I've got to vote for how many units. Ooh, my God, dead. How many dead mascots? Wow. Wow, it's not even Halloween and we're going there. Awesome. So I have deaths, money, and counts. Any other guesses as to what's going on here? Okay, it's not clear, right? It's a little vague. So one thing that we take special pride in ESRM, but everybody should do this, is we want to bring our audience along with us, right? And sometimes it can be a delicate balance. I want to make it easy for you to see the pattern, and then also make it easy for you to maybe do some exploring on your own. But I don't want to make it difficult sometimes the data is difficult, but I don't want to make it more difficult than it needs to be to make you see a pattern. So anytime I do a crappy labeling of my axes, anytime I make the plots blurry, anytime I make it hard to see a distinguishing part of, part A, part B, part C, that makes you, the audience, have to work. And that is literally me giving you a big middle finger. That's me saying, I'm so important, I don't have the time to think about you, my audience member. I'm just going to do my deal. You can't figure out if it's dollars or deaths or numbers. Oh, how stupid are you, right? That is not the impression we want to give. We want a rigorous, professional figure that people can look at, and it's easy for them to, glancing at it, they get the big picture, right? Of course, this is limited. I don't have 7 paragraphs of my methods up there and stuff, sure. But we want to do everything we can to make the audience focus on the data, focus on the thing in question, the relationship, and not get bogged down by, what's that? I can't tell. I'm colorblind. It's blurry. None of that kind of stuff. And so that takes you all putting yourself in his or her shoes and saying, because when you're working on your lab for Professor Cafella, it's going to be like, oh, I'm working on this for like an hour and 2 and 3, and I got it. You have to remember, the person that's going to come to your figure has not been playing with the data for several hours, doesn't know that that's square meters or that's degrees Celsius or whatever. They don't know that it's the average. They don't know that it's the standard deviation, the standard. So all this kind of stuff, we want to be respectful of our audience and communicate to them. So part of the issues here, as you identified, is the axes are not really labeled, right? So it's a bunch of numbers, but you guys had to guess as to what maybe the numbers could be. Yeah? Okay, so that's a problem. Any other issues here you guys see? Okay, good. Right. So there isn't a summary and an overview. Like what is this? I have no idea. Somebody else had some.
The colors are too similar, and the numbers are too close together.
Okay. So the white, dark gray, light gray are kind of similar, and the axis is, what the hell is that? Right. It's like a number squished on top of another number, squished on top of another number, squished on top of another number. Again, that's a big middle finger to the audience. I don't care about you. You go figure it out. You go squint, right? Okay, good. Anything else? Any other? Yeah.
It doesn't say where it's talking about. So it's
Yeah.
West Coast, Central, and East.
Right. So is that
Of
Asia?
what?
Is it, what's that?
Of what?
That's right. That's right. So is it Asia? Is it Australia? Is it, who knows, right?
The additional parts on top of each one, what are those indicating?
Yeah, the sort of hairy line things of the bars on top. What the heck is that? Okay, good. All right, so let me give you a revised version of this graph, and then we'll see if it makes sense. Yeah? I mean, now, depending on how you're doing this, if you're doing this on a poster or something, it might be different. But generally, for publication stuff, for a graph, a visual display, we put the legend or the label on the bottom. If it's a table, we put that on the top. So in this case, since it's a figure, we put the label on the bottom. It could also have a title. We could very easily have a title just across the top. That would not be a bad thing. But if we look down at the bottom, that sucker tells us this is actually minor league baseball teams. It tells us how many things we measured. So it tells us how many in our population that we sampled. So a total of 42 different teams. And this was in 1999. So we're getting more specific. Okay, okay, this is historic. Okay, I see this, I see that. Now the y-axis is labeled. This is costume volume. Sorry, not deaths. Surprisingly, not deaths. And it's in cubic meters, right? So another good practice here is label the variable, label the axis. This is what the thing that we're measuring is, and then give us the units, usually in parentheses, right? So okay, so this is the volume of but is it cubic feet or whatever? The units are in that little parenthetical display. Cool. And then so then this is the conference division, the West Coast, Central, etc. So that's the subgrouping of the baseball teams. And then on the upper right, there's a little a text inset. This could have also been put in the legend, the text, but it's also fine to have it up there. So this says the bars are means. So they're the average of all the teams that were, say, on the West Coast, the average of all the teams that were on the Central Division, the average of all the individuals that were on the East Coast. And that's the average. And then the whisker thing is one standard deviation. So now I got it. Now I see what the variable is. I see what the time frame is. I understand. So same data, just presented more elegantly, right? And there's nothing wrong with this guy's not going to let me go back. Oh, great, that's cool. Anyway, okay. How about this one? What's going on here? Yes.
I think it's trying to show that, like, in between the numbers, like, there is, like, a percentage, like, raise. It's not like the overall percentage. It's, like, the jump between the two numbers, but it's misleading because it makes it look like the petroleum prices went down, when in reality, they have gone up, just at a lower rate than, like, previous, if that makes sense.
Yeah, so this is called propaganda. So this is someone trying to actively mislead you. And this is more and more and more common, particularly in things like social media, particularly in politically oriented communication media. This is not about respecting you, the audience, and let me give you the information and let you make your decision. This is me trying to sculpt what you think you're seeing and actively mislead you. So, right? So this kind of stuff is just crazy, right? And so the number 30. So the quantity of 33.71, 40.62. Okay, that's higher. Okay. The 71 is higher. The 80.73, why is that? Why did that dude draw that arrow down and make the top of the bar down, right? So this is telling me this is not a serious person. This is someone attempting to deceive me, and they're counting on me glancing at this thing and just glancing this from afar and seeing that the up, and then bad, something down, or these guys were doing this, right? And so this is bad stuff. This goes on all the time. And this is not a problem for some weird Epoch Times. This is not a problem for some weird BJP political party in India. Here is the Wall Street Journal. And so this is a one of their op-ed pages from a few years ago. And so this was when there was a debate about a tax policy and what we should do with taxes, right? And so in this case, the quote from the article was that this is when President Obama was in office. President Obama asked the wealthiest Americans, quote, to pay a little more. The mathematical reality is that Washington will need to soak the middle class because that's where the big money is, right? So the implication is, hey, the middle of the distribution is where the money is. And to support that, they give us this figure. What do you think about this figure? Okay, I see. So the confusion is, hey, there's money. So this should be income. So down the bottom here, this is like I made $30,000 this year, I made $60,000, whatever. And then this is how much of our overall tax income we'd be getting from Group A, Group B, Group C, if that helps.
Is this like the current, like before what Obama's asking of like the?
To give the context, this was when there was a debate going on. So
They like this is like what we could do right now.
yeah, so this is like saying so there was a proposal from the president, and the representatives were discussing what to do. And so they were like saying, hey, if we were to do this, this is what would happen. And so they're saying, hey, if we follow your plan, this is who's gonna pay, right?
It's like supporting their idea that Obama is like targeting the middle class because it puts the income gap like huge in the middle, but as it goes to the sides, it's like a lot smaller.
Yes. So that, again, if I glance at this sure looked like what these guys were talking about. They were saying that, oh my God, your plan is going to hurt the middle income people, right? Why? Because I look at the distribution and there's a big bump up in the middle. So that seems like what these guys said, right? Deception. You might use the word lying, right? At a minimum, intellectually dishonest, at a minimum. So what's going on here? Let's have a look. So this axis here, this looks cool. This is fine. Ain't no problem with that. I got 0. I got 0.2 of a trillion dollars, 0.4 of a trillion, 8. Right? That's what we expect. I got a line here. It's even. There's evenly spaced here, evenly spaced here, evenly spaced here, and this number 0.2, or excuse me, like this number 0.4 is twice this one. Right, this 0.6 is 2 more units, etc. So that's how that looks legit. That's all good. But then let's have a look at these categories. So first we have a category that is $0. So somebody makes absolutely no money. So I guess that's all the babies. So shocker, if you make no money, you pay no taxes. Okay, good. And then this next group is people that make $1,000 to $5,000. $1,000 to $5,000. The next group is people that make $5,000 to $10,000. Okay, and then it's 10 to 15 and 15 to 20. This is like okay. So we're kind of stepping up in groups of $5,000 a group. Yeah, 25 to 30. Oh, what happened here? Oh, now right here. Now we're 10,000. Oh, so now a bar is a gap of $10,000. And then, oh yeah, this one's 10,000. Oh wait, now this one's 25,000. This one's 25. Oh, this one's 100,000. Oh, this one's 30 or 300,000. This one here is 500,000, and so on and so forth. And now we're starting to get squishy again. So the argument is, oh, the data is all there, but they've actively confuse you. You're expecting the data bins to be fair. You're expecting the data bins to be consistent. So when you glance at that figure and you see the lump in the middle, like, oh, those guys are totally right. This tax policy is going to screw the middle class, right? Active deception. So if instead we were intellectually honest and graphed it out, there's different ways to do it, but here's one example. This is where the taxes come from. So the taxes are coming from the folks in the highest quintile. So the wealthiest folks are paying the most taxes. That's the reality. Now, I'm not saying this is the right tax policy, the wrong tax policy. I'm just saying we should have an honest discussion as to what the numbers are. Increasingly, yeah.
Sorry, I had a quick question. So like by them spacing it out, like really like make it really short at the beginning,
Mhm.
and then getting really like
Yep.
like bunching the numbers together, it
Yep.
kind of like created that like false like
Right. Hump,
thing.
yeah.
Because like we continue to go up by like 5,000, like you would see how it's more linear than like.
That's right. Yeah, so they wanted it to look like something, and so they had to manipulate the figure to give them what they wanted. That is the opposite of data exploration. So I have a prediction that data will fall this way. Maybe they fall that way, maybe they don't. But if they don't fall my way, I don't then change my axes to make it look like it happened, right? We're interested in reality. We're interested in how the real world actually works. And so if it does work, that giving this mouse this drug cures it from cancer, I want to know that. If giving this mouse this drug does not cure cancer, I also want to know that.
Also, sorry, I'm just
No, you're good.
like, understand that graph. Like the majority of people are in the middle class, like that's why it's called the middle class. So it's like, is it just kind of creating like more people are going to be making $100,000 to $200,000
No.
like feeding into the
No,
taxes?
no. What they're saying is there are more voters who are in the middle class, and so what they're trying to do is get those people to not support that policy by making it look like they're being differentially attacked, and they're not attacking the folks that are most able to pay it. And so that's not. This is the reality. That's not what happens. What happens is the folks that make the most amount of money on the far right are the ones that would be contributing the most, but that doesn't make their case for them.
I was just trying to understand how they could get that big of a leap unless they were straight up like screwing with the numbers. Like,
They were screwing with the bins. They were
yeah.
screwing with the bins. So if you did something like this, which was a fair representation, it would never look like that. But if we like make this guy has got 30 cents in this bin, and this guy's got $1,000 in that bin, you could squish it and pull it and make it, and so that's what they did.
I think the tax bracket also stops at $500,000, so dividing it by bracket is more accurate because like
Right.
10 million and 1 million
Right.
don't get taxed.
Yep, totally. Cool. Okay, good. How about this one? So here is this is young workers like Facebook, Apple, and Google. Is this easy to understand? Is this easy to read? It's a little small, right? But even if it wasn't quite so small, okay, let me look at that. Okay, look at that the thing, and then okay, what's that? What's that one? Whatever. I mean, there is data there. This is not a deceptive thing, but this is an example of something that makes it a little hard to read. How about something like this? A little easier to read? No. How about this? Okay. So sometimes it's making sure we're being fair with the labels and this and that. Sometimes it's making the labels bigger. It's making them in a different way. So in some cases, it's I don't have more lines over here, but I've given the reader I've put the value overlaid on that bar so you can both see the overall trends from the graph. But then if you're really curious as to what the actual number is, you can actually look at the specific value, right? So again, this isn't magic. This isn't a program's not going to spit this out and do this for you. This is something you're going to generate and go, oh, you know what? I should probably add on some text here. I should probably make this text thicker. I should probably make like that kind of decision, right? So as we do this, again, that iterative process, you can take that first table, the table looks kind of lame. Okay, let me maybe make it try as a visual display. Okay, yeah, that's okay, but it's still hard to read. Let me start adding more stuff. And over iterations, we can make it stronger and stronger. So again, I would argue, I think you guys would argue that this is better than that. Okay, cool. All right. How about this? How about this? So here we go. Here's one talking about ChatGPT is causing people to lose jobs. So stare at this for a second. See if this, if you believe this or if this makes sense to you. Yay, nay, good, bad, okay, not okay? What do you guys think?
You say earnings on the right-hand side, but the vertical axis doesn't explain what type of earnings, whether it's USD, you don't see if it's actual individual dollars,
Okay.
hundreds of thousands of
Okay,
dollars.
good. Could be more specific. Good.
Is it percent change in monthly earnings? Like, because it's just like also, is that what it's trying to say?
I think it's I think it's proportion, but I don't. But I'm not sure. I'm not sure. So it kind of looks like there's some kind of so these guys have sort of told us, hey, this is where the thing happened. Whatever the thing in this case, they're talking about introducing ChatGPT, and there's some conditions over here. There's some income data over here, and then after there's some income, and it seems to be crashing down, right? So okay, cool. That seems to sort of help us. There's some lack of clarity maybe in terms of what this actual number is. This says change in employment and earnings, but it doesn't tell us if it's absolute, if it's a percentage or what. But still looks like the trend is down. Okay, cool. How about this one? This is daily active users of social media platforms. Is that easy to understand?
More easier than the last one.
For sure.
It looks like something's going on with X. I mean, like that's an understatement, but right. But the data is telling us that here's group one or thing one or product one. It's kind of like from here, and it's going up. And this thing is kind of sort of similarly going up, and this one's kind of similar going up. They're all kind of more or less doing something similar, but this dude is like what? It's got a musk infestation or something, right? How about this one? Does this help? So this is winter ice cover. And so these are all the different years. So every one of these guys is a year, 1973, 1974, 1975, 1976. And here is the historic average. So average all the years in whatever, February, and here's the February average. So this is the historic average. And this article came out in January of 2024. So this was just the 23 to the early part of 2024. So is that a clear understanding of what's going on here?
It looks incomplete because they did it in the middle of at the beginning of the average, but.
Oh, right. But it's because it was only in January when the article was published. So right. It'd be great if they, if we could redo this maybe in July or something after we had the whole thing. But I think this does a pretty good job, right? So all the data is here. So all the stuff is there. If you're really curious, you could see it. You could see the lowest year ever. You could see the highest year ever. But it's sort of in the background, so we've kind of grayed that out. So it's there if you really want to look, but it doesn't suck your eyeballs. Your eyeballs get sucked to the average, this brightly colored line. And it seems pretty clear that at least so far in 2024, we're looking really, really different. The ice is looking really, really different from all the years between 73 and 2024. So I would argue that's a pretty effective way to make that change. Okay, so let me ask you. So let's talk about what makes something an effective graph, an effective tool. And people write whole textbooks and textbooks and textbooks on this. So I'm going to show you some of my favorite ones. So let's look at some stuff. Now, when we talk about this, sometimes people say, "Oh, Dr. Ray, I don't know how to make a graph. I can't get on my computer." Let's look at what people did before we had computers. So stare at this for a second. This is a famous figure. This is from 1786. And this is Denmark and Norway. And so here we have years. And so if I'm going to be presenting a figure in a talk, ideally you just have the most perfect figure in the world and let me get it up there. But, I've been blabbing on for a while. You guys are like, when's this guy going to shut up? I really want to go home and sleep. And after a while, it just starts to become hard, right? So when you're giving a presentation, and the goal isn't me to ask you questions and tell me what's good and bad about this, but if I'm just giving you a presentation, one of the good skills is to let me orient you. Just like I want to have a well laid out figure, let me help you. Let me introduce. I know you're sleepy. I know you're tired. I know you need coffee and it's like a long day and everything. So let me give you a hand. So first thing what I'm going to do is I'm going to orient you, the viewer, to what we're looking at. So I'm going to say, oh, this is, like essentially like the title. Hey, so let's look at what was going on with international trade between a couple countries. In this case, we're looking at Denmark and Norway. And so this axis here, and so usually what I'll do is I'll orient you to the axes. So this one here is time. And so this starts at 1700 and goes in 10-year increments to 1710, et cetera. So we go from back in the day to more modern time right here. Usually that's what we expect. We expect this to be a low value in say like an XY plot, this to be a low value, this to be a high value. And then similarly on the Y-axis, low value, high value. In this case, what we've done is this guy right here is going to be, let me pause on that. Okay, so we have two lines here. We have this yellow guy here, which are the imports. So that guy right there. And then this guy is the exports from Denmark, right? And this is the imports and exports from Norway and Denmark to England. Okay, everybody with me? Now, I could have just done the one line, imports. What were imports over time? Okay, it's like, and plotted up and plotted up and plotted up and plotted up. And how do we do this before computers? Well, before computers, we looked at every year. And we said, and this year it's value, whatever. And I went and put a little, you guys can see and I put a little dot right here at, whatever the value was at 1760 or whatever. And then I went to the year before and I put a little dot. And I went to the year before and put a little dot. So I had a bunch of little dot. And then I just took a pencil and I traced between the dots. And that's how I got a smooth line, right? That's literally the same thing your computer program is doing. It's just doing it way more, way faster than you and probably a finer scale, but that's the same idea. Okay, so I did the imports, boom. Okay, now I do the exports. Now, if I could have put a black line and a black line, that would have been okay, but I would have had to search. So the author decided, hey, maybe if I make these different colors, it'll be easier for you guys to see line 1 versus line 2. And so, and then had the invention of adding a fill in here, right? A fill in here. And so in some cases, the imports are higher than the exports. In some cases, the exports are higher than the imports. And so I'm going to add a color ramp and I'm going to add some words to emphasize that. So when I look at this, it looks like initially in the trade balance, it looks like this was going against England. This looks like it was benefiting Denmark and Norway. But then at some point, something happened here and something changed. And all of a sudden at this point, from this point forward, it looks like England started doing better. And in general, the imports look more or less kind of stable, but it was the exports that really jumped. So now when looking at this figure, it becomes very clear that something happened right around here, right? Something happened right around here, and it seems to have something to do with exports. And so that's a great illustration of a data visualization that can help lead us to ask other questions. A great visualization both shows you a pattern and engages you, right? That's not always possible, but like, ooh, I wonder what happened. Ooh, now what's the next part of the story, right? What's the next mystery that we're going to uncover? So great graphs, does that make sense? Everybody cool? Okay, so great graphs, and again, this doesn't always work all the time, but as much as we can, really effective high data density, a lot of information in there. Remember I showed you that one where it was like all the ice cover? There was thousands and thousands of data points in there. It didn't screw with your brain. You could still see stuff, but yet you could also ask some of your own hypotheses that you invented staring at that graph. So data density is generally good. And the more dense data you have on a figure, I mean, it could be so dense you can't make sense of it, but an appropriate level of data density will both show, allow you to show the big picture or the story you're telling, but it also gives me, the viewer, an option. I wonder, might X be happening? Let me look. Oh no, it doesn't look like that, right? So that is creating an engagement with the audience. Next, a great graph. The main conclusion, there could be many conclusions, but at least the core conclusion should be obvious. The trade deficit was this way when we started, and when we finished, it was that way, right? A is clearly related to B, right? That kind of thing. Or A is totally unrelated to B. That we want it to be nice and clear. And so the choice of figure is going to help us with that. So some data formats are better to show this kind of contrast or make this one a bit easier. So it's not just that everything goes into a scatter plot or everything goes into a bar chart. You're going to want to, once you understand how to make these things, you're going to start to make a decision. Is this type of data better here? Is this type of data better like that? And then what will be wonderful, we can't always do this, but what we can, elegant. What does that mean? I don't fucking know, right? But it when you know it when you see it, right? You're like, oh, this is beautiful. This is a really aesthetically pleasing. The colors here really are easy for me to, they're very intuitive, right? That kind of stuff. Again, we never reach that, but we always want to be building towards more elegant. So most of these principles that I'm going to show you, everybody has opinions about figures. I tend to have very strong opinions. It's how I was raised about plotting things with my academic lineage. But most of I was heavily influenced by this guy named Tufte, Edward Tufte. Ironically, I was just, Nicole isn't in this class, but ironically, I never talk about Tufte to you guys. And in our trip to sample burned soils on Friday, this came up in topic. So that's how nerdy our van conversation was. We were talking about data plotting. Anyway, so this guy was a really cool dude. He is a retired professor. He used to go around the country doing seminars. And back in the day, when campus supported your learning, they used to give me money to take you guys when he would come to Southern California, and we would go. So this is a previous group of students, and we went down to LA, and he gave us all a copy of his books, etc. Anyway, it's great. If you are interested in data visualization, I strongly recommend you guys get one or more of his books. He has several. And it's they're both beautiful things just to look at. They're really cool, just like as a coffee table book, just to flip through. But he also has a lot of great guidance and suggestions and things of that nature. So a lot of this stuff is drawn from things I've learned from him and all that kind of stuff. Okay, so a few principles of excellent graphing. One, show the data. So summary statistics are great, but where you can, show the full data. Ideally, induce the viewer to think about the substance of the findings rather than the methodology. This is very, very common with you guys in capstone and all this kind of stuff. And young scientists, you're like, dude, I did 18 months worth of work. I wanted you to know that I did 18 months worth of work. Nobody gives a shit, right? I understand you do. I understand you put your heart and soul. I understand you leverage your house to do this, but nobody cares, right? So you have to just kind of breathe, go on a jog or do whatever you need to do to get out of your brain and then get back to it. People just want to see the conclusion, right? So what we want to do is we want to get to thinking about the relationships, not how much work you put in to get this. You want to avoid distorting data, like we saw those examples early on, vague or intentionally misleading stuff. Where we can, it's nice to present many numbers, right? So that's that data density. So many numbers on one plot is usually helpful. We have to do some work to make large data sets coherent. And whenever we do stuff, we'd like to encourage you to say, what if? Let me look at A versus B. Let me look at A versus C, etc. A couple more, and then we'll look at some more figures here. If you can look at several layers of detail, that'd be great. So sometimes you can have different symbols or different colors or different sizes of symbols that can give us extra levels of data or other values, etc. And yeah, that's enough for now. Okay, so let's have a look at this. So this is from Galileo's notebook. Yes, that Galileo. And so before he had his killer telescope, he looked up in the night sky. This is what he saw. So he sketched this out. So I saw these stars and this constellation. Okay, that's cool. All right, awesome. After he made his telescope, this is what he could see, right? So this is a lot more information. And so this is maximizing the data to ink ratio, maximizing the data to space ratio. And we're getting a lot more insight from the figure on the right than on the left. We also want the viewer to think about the takeaway. And probably this is debatable, but this is probably, at least for things like spatial stuff, this is probably the most famous. Well, you'll see my most favorite graph, but for public health, certainly this is the most famous plot in the world. So have you guys seen this before? No? Okay, so stare at this for a second, and then I'll explain to you what it is. Okay, so what we're looking at is the father of modern epidemiology, named John Snow. And so this is London. So we're looking at a street map of London, England. And people were getting sick. People were getting sick and dying from this infection of a disease called cholera. And nobody could understand it. Don't know what's going on. Vapors, I don't get it. I don't understand what's happening. So he said, well, maybe I can get some information if I essentially do GIS before we have computers, right? So he took down his map and he started going around, knocking door to door, and he went on to people's houses, and he said, hey, is anybody here sick? Is anybody, feeling ill? And some people said no, and some people said yeah. And some people said, well, I'm sick. And some people said, well, I'm sick, and my husband's sick, and my kid's sick, and my, like that kind of thing. And so he could have put it in a table, right? Totally fine. That's how people would have done it back in the day. And you'd be staring at a bunch of numbers like, I don't know what's going on. Instead, he put it in a spatially explicit plot, in this case on a map. And so each of these little black dudes here is a incident of cholera, an incident of that disease. And it's a little bit zoomed out, so let me just zoom in a little teeny tiny bit for you. And so here's the core center of this. And do you guys see any pattern here? Yeah, so Thomas is saying on this right here, that like this dude's a little tick, here's a little tick, here's a couple, there are 3 ticks, here tick, here tick, tick, and this is like tick, 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 like way more ticks. And so he's like, dude, something's going on with this, right? So nothing over here, nothing over here, nothing over here, but this dude, there's something going on here. And so this was before we had indoor plumbing. And so this is when we had a water pump in the street. So if you wanted to get a drink of water or to get some water to wash your face or whatever, you went out and there was it's like you like this, kind of up, down, chink, 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 and then that created suction, and then the water whoosh, whoosh, whoosh came out, and he's like, there's something wrong with this pump. So he went out and he took the handle off that pump, immediately killed the infection. Nobody got sick after that. So what was happening was the water source was contaminated. Cholera is a waterborne disease. Some, human waste or something had gotten into the water pipe, maybe a cracked pipe or something of that nature, and got in, and then everybody that took a drink of water was infecting themselves. So by taking off that handle, stopped the infection, right? Would not have been possible, would not have seen that relationship if we didn't have a good, solid, robust data visualization. Made a huge difference. In this case, saved tons of folks' lives, and this is where that Broad Street pump was, right? So again, a good data visualization is going to induce the viewer to think about the pattern, not how many hours, people went door to door knocking and saying, "Hey, you okay? You okay? You okay? You okay?" Right? I get it. We all put in thankless hours, and it's hard and everything, but we want folks to think about the data, not what we've done. Okay, cool. All right, and then we want to avoid distorting the data as much as possible. So here we go. Here's another example. So let's look at inflation. This is the relationship between inflation and unemployment. Oh, yeah, sorry.
I did a research basically on a specific rock formation, and they explained how they researched it by hitting it with water in a controlled setting.
Cool.
And its release of nitrogen. Would that be an acceptable explanation of how you got your data because you're not doing it in a natural environment?
Sure.
Okay.
Sure.
So
Totally.
explaining how you get your info is sometimes different than over.
Oh, totally. Yeah, I'm not saying we should not tell people how we got our data. No, I'm not saying that at all. No, you want to tell people your methodology. I'm just saying in your reporting out of your data visual, that's not the place for that. That's all I'm saying. Yeah, totally. Okay, great. Okay, let's have this one. Okay, so this is like, hey, dude, inflation. Okay, so here we go. So let me, again, orient you. So here's unemployment rate. So this is low to higher, and this is inflation. So this is low inflation to high inflation. So, right, so this looks like, you guys correct me if I'm wrong, but it looks like, hey, when we have, let's see, when we have this level of unemployment, we have this, when we have sort of low unemployment, we have high inflation. But as we go down here, and as unemployment gets higher, inflation goes down. Does that make sense? Okay, except I didn't show you all the data. I showed you the subset of data that was convenient to prove my point. So if I add on the rest of the data, it doesn't look like that, right? Maybe no relationship, or if anything, maybe the reverse relationship, right? Maybe instead of a relationship like this, maybe it's a relationship like this, but certainly not this clear one here. So another principle here, again, not that we don't want to distort data, but also another way of saying this, don't cherry pick your data, right? Don't do what the Wall Street Journal was doing, the binning or the subsetting, or I'm going to show you these 5 parts or whatever. Okay, cool. And then here's an example of that. Present many numbers in a small space. So let's have a look at this. Everybody take a breath. Okay. Okay. Yeah, a lot of stuff. So here we go. So this is time on this axis, right? From back in the day, 1990 to 2020s. Okay. And this is housing price, house prices. And so essentially low to higher. So up here is higher stuff. And this is where we are in reality when the folks made this figure, and then this to the right is the prediction. So we're not sure. And so we're doing a trend line here, but it gets the farther away, the less accurate our prediction probably is going to go. So stare at this. See if you guys can see see if you can take any takeaways from this.
Colors are too similar, so you can't really
Okay, so maybe some of like, let's say the this guy and the this guy, or the this guy and this guy, they're a little bit hard to see. Okay, good.
Or even just Germany and Italy.
Yeah, that too.
Yeah.
Yeah, these two. Okay, okay. What can you see? What can you take away?
I think it's kind of generally saying that from like 2012 to like present time, it's like gonna gradually,
Like in this area?
yeah, it's gonna like the house prices are gradually increasing kind of everywhere. Um, yeah, ever so slightly.
Yeah, so when you see a figure like this is standardized to whatever the starter time is, right? So this is 100%. So this is standardized to when we started doing the plot. So it doesn't matter what the number is, but that's just we're going to use that as the jumping off point. And if it didn't change, it would stay at 100%, right? So no change. It looks like when we started off, some places like this blue guy here, which looks like Britain, it was like, oh, dude, cheaper house, cheaper, right? Other places, starting off, like Italy, immediately, more expensive, more expensive, more expensive, more expensive, more expensive. Yeah? But just about everybody after this, a couple decades, Italy is cheaper. Yeah? Everybody else, though, more expensive, 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 more expensive. Everybody seems to have reacted to which, you guys are a little young, but this was the Great Recession, 2007, 8, 9, around that time, right? And everybody's crashing. This is an example of a lot of data. Agreed. We could have it maybe better colored or dotted and dashed so it'd be easier to follow one or the other. Totally agree with that. But it actually, you can start to do your own comparisons. Hey, what happened with the Great Recession? Hey, are the European countries different from New Zealand? Hey, is this or that? And it's like, dude, I don't know. You go look. I gave you the data in a format that you could start to ask. Did they all follow the same trend? Or some guys going this way and other ones going that way, right? So that's an example of allowing richer comparisons when we have really robust, and allowing deeper conclusions when we have a lot of numbers in a small space. Okay. Now, we can have, the more data we have, sometimes we're like, it's too busy to plot. Sometimes it just takes someone with some good visualization skills. So let's look at a super large data set. So this is vaccinations and infectious disease outbreaks. Some people in our country don't think this is real, especially right now. So let's look at this. Okay, so this is time. This axis here is time. And let me zoom in just so it's a little small. very easy for you, the audience, to come in and just look at it. Okay. Look at a couple more, and then we're going to end on my favorite graph of all time. Okay, how about this one? So here we go. This is Scripps Institute of Oceanography sea level data, and they have sensors from different parts of the world. In this case, we're looking at stuff related to El Niños. So here's the year back in the day to now. And this is the variance of what's called the Southern Oscillation Index. And that's a measure of strength of El Nino conditions, which is one of our atmospheric conditions. And so this is the difference. And this is the data from Tahiti and the data from Darwin and Australia, which just are two of the places where we measure the conditions. And so pretty easy to see that, okay, in some periods, we have Tahiti is anomalously low and Darwin is anomalously high. In some cases, they flip, right? And so they kind of, jump back and forth. And so by having this, the Southern Oscillation Index, if I just had this, you might look at it and say, okay, cool. Okay, some nerdy dude's index. Okay, it went up, went down. I don't know, what does that mean? Because it went up, I don't know. But by adding in some contextual data here for one extreme or one representative site, let me say it that way, to another representative site, you can get some more interpretation. So sometimes you want to add in some additional stuff. Maybe it's a date or a point to show when a historical event happened. Maybe it's some subset of the data, maybe it's somebody else's data, etc. Okay, cool. All right, and now we're ready for my favorite figure, and then maybe we'll take a break here. Okay, so I actually have this in my office at home. That's how big a nerd I am. This next one. Okay. So, you guys like, Dr. Egg, it's really hard. I got my screen. I don't know how to show this or whatever. Okay. This is Menard's 1869 1869 plot of Napoleon's tragic military campaign trying to take over Russia in 1812. So stare at that for a second. Now, the original is in French. My version is in French. So this is the English translation, just so it's a little bit easier for you to read. But all the words are translated into English, but all the everything else is a direct reproduction of what was made in 1869. So stare at it for a second, and then I'll give you some context if you're having a hard time figuring out what's going on. Okay. Can somebody explain what's going on, or should I give you guys some more orientation? What's that? Oh, okay. So it's too small. Somebody want to take a stab?
The red one is the amount of men who enter Russia.
Yes.
And the black one is the amount who loses.
Yes. Good. Okay. So, oh my God, it's only a piece of paper. We have to have an interactive TikTok plot and bullshit, right? It's interactive plots are great. Interactive dynamic plots are really cool, but that's not a replacement for good design, right? So just because something blinks and winks doesn't mean it's more helpful or more elegant or whatever. Okay, so what we're trying to show here is what happened with so Napoleon is a little man that wants to take over the world, right? And he's like, I'm going to go take over Russia because they suck and I want Russia, right? So he goes, come on, dudes, mostly dudes. Come on, dudes, let's go kill some people. Like, okay. So this is there's lots, there's many levels of data on here. So oops, my thing doesn't seem to show when I hover over. Okay, there we go. Okay, so this is where we're starting. Okay, so we're starting here. So this is also a map. This is also a GIS. So this is a map of Europe, right? So Moscow is over here. Here's over here, we're in France. And the width of this plot is how many dudes were in the army or in the group of men at that point. Okay? So we start out and we have a lot of people. We have this many. And we start marching like do 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 do. We march, and then we kind of turn. And some guys are like, "F this," and they leave. Right. So this group breaks off, and they go over to here. Okay. So the total width of the total number of people gets a little smaller, right? Because we shaved off some of those dudes. Okay. Now we're kind of boop 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 boop, and then like, hey, send some dudes to Poland. So then these dudes break off, doop-a-doop-a-doop-a-doop-a-doop, and they go over here, right? And so then these guys keep marching. But then look what starts to happen. Okay, so we're marching, and then nobody broke off here, but now it's getting thinner. And march a little farther. Nobody broke off here, getting a little thinner. Nobody, a little thinner, and a little thinner, and a little thinner, and then a little thinner. And then, this sucks. And then like thinner, and then, thinner, and then, and then, thinner. And then, and by the time we get to Moscow, we're a fraction of the number of folks that we left France with.
Is it because they died or is it because they were treated?
It's because they froze to death and they got disease and they died. So these folks are dying on the way. So ain't no Russian fighting going on. So all this is foolish military campaign that should not have gone at that time of year with that type of preparation, with that type of, foodstuffs and all that kind of stuff. Then we get here, right? And they're like, I guess we can't take it. We better go home. So they start going home, and now they're dying still. So now we're getting smaller and smaller. More guys die. More guys die. More guys die. More guys die. More. And then they hook up with these dudes from Poland, like, dude, what's up? And they're like, we suck. And now it gets bigger. So now those guys start to die, right? So oh my God, now they die and they die. And so at the very end, a few guys return, but mostly because they were reinforced from this one little expeditionary force that went over here, right? That's a massive amount of data, right? That's a massive amount of data. So this is telling us, and then this plot down here, and its reference with each of these drop-down lines is telling us what the temperature was, right? So they were freezing to death. They were having a hard time. So check this out. We have a data plot. We have a map. We have the number of dudes. We have the temperature. We have the geolocations of where they were breaking up. This is a tremendous amount of data. No computer here, right? This was not a standard plot. This guy just thought about it. He goes, hey, you know what? I think I could make a really elegant presentation if I just think about this, right? And so this Menard's plot of Napoleon's March is a fantastic illustration of what's going on. And so if the lore was, the Russians are really good fighters, or they just put up a better fight, no, right? If you look at this, you can see there was no contact with these two armies when people started dying. And it was something else. So that speaks to not bad generaling in the battle. This speaks to bad generaling in the whole idea of doing a campaign at this time of year with these people. That leads you to a very different conclusion, right? I guess we got to train up. We got to make the guys more manly, right? That kind of stuff. That's not what it's saying. It's saying this is bad leadership. This is bad decision making. This wasn't a strategic error. This was a fool's errand to try to do this, right?
I have a question. The scale of degrees seems to be in bar degrees. What is that?
So this is, I don't know. This is Celsius, Fahrenheit. I'm not sure.
Is that a K?
Oh, it's Kelvin.
Oh, it's Kelvin. Okay.
But it's yeah. So yeah. All right, cool. So I can keep going on. Love talking about graphs. We'll wrap up here. We'll just say, here's a modern example. Here's a modern example from how we're doing things differently, right? So the figure on the right, so these are for hurricane prediction models. So something that a lot of people care about, a lot of people are worried about. Hey, how do I plan for this possible storm coming to me? And so in this case, the storm is in the Gulf of Mexico. Gulf of Mexico, ain't Gulf of America. Let's call it real, Gulf of Mexico. And so all of these guys, these are sometimes called spaghetti plots. Okay, so this is all. We use many different models, and we have different assumptions, and we run all the different things, and we run them all together, and then we look for consensus. So this is what maybe the weather nerd, maybe the meteorology lady is like, oh, let me see that, right? Okay, cool. Yeah, this is really cool. Joe Blow doesn't care about that, right? The guy that's trying to figure out, do I need to evacuate my house or not? He don't care about 17,000 different plots. He wants a clear, concise takeaway. So this is what we have. This is the actually it's been modified since then, but this is one of the innovations, which is, okay, here we go. So this is called a cone model. And so this is the same exact stuff as this. It's the same data, but rather than just sort of plotting every single data, some cases that's good. But most people don't have the sophistication to figure that out. Some people look at this and go, oh my God, it's going to hit us in Texas, right? Or oh my God, it's going to hit us in New Orleans, right? So this is the probability. So here we start, this is time step 1, maybe it's a day, second day, third day, fourth day. And this is where the models agree that on average, this is where probably most of the storm is most likely to be. And then as we go, like right here, it's probably going to be here. But as we go farther into the future, there's more error, and a little small error might lead to the storm being in a very different area. So as we go forward, the so-called cone of uncertainty gets bigger. And so this is a lot easier for people to understand. So this is like, I guess maybe I should worry. If I see this, I'm like, oh, damn. You know, if I'm in the Florida Panhandle, we should get out of here, right? And so again, every element is useful. Every element is good thing. So to wrap up, I'll just reiterate the things we talked about. Show your data, the general principles. There's always reasons to maybe sometimes deviate these occasionally, but on average, the best thing for you guys to do is show the data. Allow viewers to think about the substance, not all the logistics that got you to this point, but show them the substance. Avoid distorting data like we saw at the start of this. Where possible, present many numbers in a small space to help people be able to ask their own questions, all that kind of good stuff. Make large data sets coherent. Encourage comparisons. Depending on how your data is, use graphical formats that allow you to compare this to that and that to that, etc. Reveal levels of detail, clear purpose. And one last thing I'll just say that I haven't said, but I'll just this was drilled into me when I was your age. And of course we should be elegant when we can. But ideally, and again, in this class, you guys are mostly going to be working on the visualization part, right? But a sister component to this is when we work on things like, let's say our poster up here, we have some text and a figure, or we're writing a paper, so we have some text in our figure and some text in our paper, and then we have our figure. The best stuff, the goal is I should be able to read the text of your report, and maybe not every single thing, but the main takeaways. I should be able to get the main takeaways just from reading the text of your paper or the text of your poster. Similarly, I should be able to look at your figure and get the main takeaways just from looking at your figure. Now, the two of them together, the written word and the data visualization, will reinforce each other, and that's the best. And there's strengths in words that that visuals don't have. There's strengths in visuals that words don't have. So you want them both. But a really good job means that I can read my figure and I don't need the text to get the key things. I can look at my poster, my words, my whatever, and I don't need to see the figure to get the main takeaway points. So that's always what we're building towards. Cool? All right, great. So So we'll just end today. I'm just going to show you a poster that we just presented, and you guys can say whether you like it or not, don't like it, and I will not be offended either way. But let's